Okay, I'm going to walk you through the answer to the problem 5.052 from your homework. This is question is that find the I0 in the network in the figure below using Norton Theorem. If you want to use Norton Theorem, you need to know that instead of finding the VOC that we usually do for the Thevenin theorem, we want to find the I short circuit. And then so we want to find the I short circuit and R Thevenin. So these are the two things that we're looking at. So in order to find the I short circuit, I'm going to short wherever I want to find the I short circuit. If it was supposed to be Thevenin theorem, I would have opened this part and then found the VOC across it. But now I'm finding the so in order to do that, I'm going to have this 12 here and then a 6 over here, and then this part is going to be shorted, and then I'm going to have a 3K over here and then 1 milliamp coming down, and it is going to be a 3K over here, and then so this is a 3K, this is a 3K, this is a 6K, this is shorted, this is 12 volts. So in order to find the I short circuit, I want to do two source transforms, one from voltage to, the first one is going to be from voltage to current. So if I want to change this part of it to a voltage and change it to current source, I'm going to have my I for the current source is going to be V over R. So the V is 12, the R is 6. So this is going to be a 2 milliampere flowing this way. So you know that this is the negative, this is the positive. So I'm going to change this with a 2 milliampere. And then I'm going to have that 6 just in front of it. And then I have a 6K over here. Then I have this short circuit current, ISC. Then I have this 3, and then I have this 1 milliampere coming down, and then I have this 3K over here. So the second step I want to do, I want to change this one and this one to a voltage source. So in order to do that, I'm just going to say that, okay, so the 2 milliamperes is still going to be here. The 6K is going to be here, and then I have this I short circuit, and then I have K over here, and then this is going to be the 3K, or is going to come over there, and then my voltage is equal to IR, so it is 1 times 3K, 1 milliampere times 3K, it is going to be 3 volts. So then I have this. So then make sure that you're doing it correctly. So this is the negative, this is the positive. Now negative, positive, and then I have a 3 volts over here. I do another source transform after adding these two up, making it a 6K. So the second transform is going. The third transform is actually going to be changing this 3 and 6K to another current source. In order to do that, so my current source I is going to be V over R. So this time my I is going to be 0.5, and make sure that you put it downwards. So I have a 2 milliampere going this way, and a 6K here, and then I have the short circuit current that I'm looking at, and then I have a 6K over here because I'm putting this 6K down here, and then I have this 0.5 milliampere that is actually going that way. So if you look at this one carefully, you would see that this 6K and this 6K are in parallel, so I can add them. I can do a parallel, so 6 parallel to 6 is going to be 6 times 6 over 6 plus 6. This is actually going to be 3K. You may want to always remember that whenever you have two parallel resistors that have the same value it is going to be half of that. So if it is a 6, it is going to be 3. So you don't need to do the rest. So you can just say that 6 parallel to 6 is 3K. So my final, and then I can add this one up with going up, this is going down. So my current source is going to go up, and then it is 1.5 milliampere going up, and then I have a 3K coming this way, and then it is going to be connected to the I short circuit. I of the short circuit, and then this is a 3K, so this is 1.5 milliampere, this is 3K, this is I short circuit. Okay, if I short circuit this part, then all the current is going to go, nothing is going this way, all the current is going to actually go to the short circuit. So I short circuit is going to be 1.5 milliampere. But then the second step is to find the R Thevenin, as we said here. The second step is to find the R Thevenin. If I want to find the R Thevenin in this circuit, in the question, in this circuit, if I want to find R Thevenin, I short it, and then I have to find the R Thevenin. So in order to find the in order to find the R Thevenin, I do not short it. I just open it from here, because this is the R Thevenin. You're not looking at the I short circuit. I open it from here, and then we do the whatever we were supposed to do. So for the sources, if it is a current source, I open it. If it is a voltage source, I actually so if I look at it here, you would see that I'm going to have a 6K over here, 3K over here. So this is going to be open. So this is going to be open. And I have a 3K over here. And then I have a shorted source over there. So I'm looking at the R Thevenin over here. So this is shorted. So this is a, and then I have, 3K and the 3K over here. So in order to find that, the R Thevenin across it, so I can say that 3 and 3 are 6. 6 and 6 are going to be, so this part and that part are going to be in parallel. So 6 parallel to 6 is going to be what? Half of 6. So 3K. So my R Thevenin is going to be 3K. And my I short circuit was, we found it over here, I short circuit was 1.5 milliampere, 1.5 milliampere. So if I want to redraw this whole circuit, I can redraw it as if I want to redraw this whole circuit, I can redraw it as this. I have let me draw it here for you. So if I want to redraw it, I say that I'm looking at these ends. So I have a 3K, I have a 3K over here, that is my load, and then I have the I short circuit, which is going to be my current source, and then I have my R Thevenin, which is 3K. So I have a 3K over here, I have 1.5 milliampere over here, and then if I'm looking at the I0, as this is the I0, so I took everything out, I put a 3K over here and 1.5 milliampere. So my current that is going to the I0 is I 3 over 3 plus 3. So this is the current division as we had in parallel circuits. So this is going to be half of the 1.5 over 2. This is 0.75 milliampere. So this is the final circuit.